Okay, good morning to all of you. So, my AV is okay. Is it audible, visible? Mm. Good morning to everyone. Is my AV is okay? Okay, thank you, Joshit and Samukshi. Thank you. So, let us begin today's session. So, yesterday we were discussing about unit commitment problem. So, unit commitment problem is optimization problem. So in this optimization problem, we have to determine which units to be operated, which units to be operated for varying loads under different constraints and environments. This is what I have explained it yesterday. And this optimization problem is solved using dynamic programming. Understood. And it is not economical to operate all the units at all times. Understood. So I have taken Raichur Thermal Power Station and totally 8 units are there, out of which 7 units are of 220 megawatt and 1 unit is of 250 megawatt. So now we have to see how to operate these units. It is not economical to operate all these 8 units at all times. Understood. So for a given load, for a given constraint, which units to be operated? This is what is known as your unit commitment problem. And this unit commitment problem, you can solve it by solving your coordination equations. And if you want to try, so whether to operate all 8 units, is it economical for a given load, or operating 7 units at a time is economical, or operating 1 and 2 units is economical, operating 1 and 3 is equal, or we operating 1 and 4 unit is equal, or operating unit 3 and unit 7 is optimal. So all these combinations you have to try by solving your coordination equations. So it is a tedious task. So therefore, how to get this one? So by using the dynamic programming problem. So dynamic programming optimization method. So we are going to solve this one. Clear? So this is what we have said. I have explained it, but I was in between the dynamic programming illustration. So in this illustration of dynamic programming, so we have considered 4 units. So you know that unit commitment problem is we cannot operate all the units at all times because of the varying load and also considering different constraints. Okay. So for that one, to illustrate dynamic programming, so we have taken this units. Number of units is 4. There are totally 4 units are there. Each unit rating is 12 megawatt and total load is 9 megawatt. So each unit is 12 megawatt means, so what is the total load all the 4 units can supply or can meet total load? So each unit is 12 megawatt. So there are 4 units are there. 4 into 12, that is 48 megawatt. So these 4 units can meet a load of 48 megawatt. Understood? Till maximum load of 48 megawatt it can meet. However, in this example, we are considering for a particular load out of this 48 megawatt. So we are taking only 9 megawatt load. Example. So if the load is only 9 megawatt, so each unit is 12 megawatt. Okay. So therefore, only one unit you can use it. Only one unit out of 4 units. No need to operate all the 4 units. So just to switch on, operate only unit 1, because unit 1 rating is 12 megawatt. So it can meet this 9 megawatt. But is it economical? Or you can operate unit 2 and 4 out of these 4 units, or 3 and 1, or 2 and 3, isn't it? So any combination you can find out. So which is economical? So this is what I was explaining. So before that one, some assumptions. So this is the cost of the unit 1, 2, 3, 4. 4 units are there. So just because some of them I have not attended yesterday's class, for them I am briefing it. Okay, so if I start in between, they may not be in a position to understand. So there are 4 units, one, two, three, 4, and minimum megawatt generation should be 1 megawatt, and maximum is obviously 12 megawatt. And cost curve parameters. In the previous class, earlier class, I've taken the cost curve coefficients or the parameters as alpha, beta, gamma, isn't it? Alpha, beta, gamma, I have taken it. But here I am considering A, B, D. A, B, D, I am taking it. Understood? That is, for PGI square, the coefficient will be AI. For PGI, coefficient will be BI plus DI, the constant. Understood? So depending on the some textbooks, they are using the cost curve parameters differently. So as per that one, you can go ahead. So here you see this is A constant. For unit 1, this is A constant and this is B coefficient. For unit 2, this is A coefficient, this is B coefficient, and D values are 0. And what is the cost equation for this one? So already we have discussed it is a quadratic equation of AI Pj square plus Bi Pj plus Di. Earlier we have taken alpha, beta, gamma here. Isn't it? Any parameter coefficients you can take it. So because in this table they have considered ABD, so even I have taken ABD. So this is nothing but cost of generation at ith unit, and PGI is the real power generation at ith unit. And what is AI, BI, DI are the cost curve parameters at ith unit. Clear? So keeping this one in mind, so first what you are going to say, only assuming first only one unit will be operating. Let us start with one unit will be operating it. So what is the recursive relation? I have explained it using dynamic programming, isn't it? So that one, what is this capital F1x means? This is the cost, minimum cost. Capital F means you have to use minimum term, minimum word use it. So capital F1x is minimum cost in rupees per hour for generating X megawatt by first unit. Understood? Hope you understood. F1 of X is the minimum cost in rupees per hour for generating X megawatt. This is the megawatt by first unit. What is the small F1X? It is not the minimum cost, it is just a cost. Understood? That is the difference between this capital F and small f. What is F1X? Is the cost of generating X megawatt by the first unit. Understood? So what is this F1 is nothing but this equation. This equation. So this equation we have to substitute it. So when you are operating only one unit, so therefore what is the overall cost? Will be your F1 assembly. If you are operating 2 units, then we have to take the minimum among those 2 units. Minimum among those 2 units will be F1x. Because there is only one unit is operating, so the minimum cost is also equal to that one unit. So therefore capital F1x is equal to small f1x. So in this one, so first let us take what is the total load is 9 megawatt. So to meet this 9 megawatt, what is the total generation required? 9 megawatt only it is required. So therefore, what is the generation here? We will consider 9 and 9. Substitute that one in this equation is equal to, that means this equation is equal to this one, is equal to half AI Pj square plus Bi plus Pj Di. Now we are having it. This is for unit 1, right? This indicates this is for unit 1. For unit 1, what are the coefficients? cost curve parameters A, B, and D is 0 for everything. So substitute it. And what is this PG is nothing but this one generation 9 megawatt. So that you have to replace it. So that when you replace it, so you substitute this AI, BI values from here. DI is 0. Then PGI is nothing but this load generation. This generation 9 megawatt. So that value you have to replace it. So that is equal to, you are going to get 242.685 rupees per hour. This is the cost. When you are getting this cost, when you are operating a single unit, that is unit 1. You are operating unit 1. Understood? So alone, when you are operating unit 1 alone, so what is the cost involved here is rupees 242.685 per hour, or 242.685 rupees per hour. Clear? Till this point, I have explained it. I have repeated for the benefit of the students who are not attended yesterday because of some placement activity. Fine. So now let us take when two units are operating it. We have taken it as a only one unit. Now let us take two units. Understood? So combination using the recursive relation. So using dynamic programming, this is your recursive relation. I given it, isn't it? So what is this capital Fnx? Today also I have repeated. What is small fny? This is a, so how you are going to define Fnx is the minimum cost in rupees per hour for generating X megawatt by n units. I am using the word units, plural, by n units. See the difference. And what is this small f and y? It is not the minimum cost. Just say cost. It is the cost of generating y megawatt by nth unit. That means single unit. Means single unit. Here. Understood? So by nth unit, here by n units. Plural. So here it is only single unit, nth unit. And what is, if y load is taken by nth unit, then n minus 1 units will take x minus y load. N minus 1 will taken by x minus y load. So what is this Fn minus 1 x of my x minus y is the minimum cost, capital F. So you have to use minimum cost in rupees per hour for generating x minus y megawatt, for generating x minus y megawatt by n minus 1 units. N minus 1 units. This is your recursive relation from the dynamic programming. So now what you do, so that means this itself is 13. I given the number for this one 13. So from this equation 13, computation is made for F20, F21, F22, etc., F29. So means what you have to do, first two units as a combination. First only one unit we have operated, we have seen what is the cost we got. 242.865 something we got it. Now let us operate a combination of two units as per this equation, recursive relation. Two units. This is one unit and this is another unit. So two units combination we have to take it. So for this two units combination, so first let us calculate F29 because the load given here is 9 megawatt. So we will calculate F29. So after calculating F29 on the same lines you have to estimate F20, F21, F22, etc. That means what? What is F220? Is the minimum cost for generating 2 megawatts by 2 units, by 2 units. Understood? This is the meaning, by 2 units. Hope you understood this one. So what is this F2 of 1 is the minimum cost of generating 1 megawatt by 2 units. And what is this F29 here? Is nothing but minimum cost of generating 9 megawatt by 2 units. Hope you understood this one. So first let us calculate F29. On the same lines we have to evaluate these things. Why I am taking it F29? Because in the example we are taking it for 9 megawatt is a total load. So we will take F29 using this recursive relation. So let us see how we are going to get it. Okay, F29. That means using this formula, I am going to write what is x here. It is 9. So what is n is 2. N is 2. Understood? F29 I am using it. Using this recursive formula, u is equal to, so minimum. So minimum of y. Minimum y means here you have to minimize the variable y. Here you have to minimize the variable y. This y. Such a way that cost should be minimum. Understood? So what is this y? Is the increment in load. What is the y? It is the increment in load. So in order to meet that increment in load, you have to increment the generation. You have to increment the generation by delta x. That is delta x or whatever it is known as delta megawatt. That is a step size of 1 megawatt. We are assuming it here. A step size of 1 megawatt. We are assuming it. This y is your step size of generation. Step size of your generation in megawatt. So this step size we are assuming it as 1 megawatt, 2 megawatt, 3 in a step size of 1. If for better accuracy, still you can assume this y as a zero point 0.5 of megawatt. Next 1, 1.5, 2, 2.5, like that you can move on. Or you can assume it this y as a 2 megawatts initially, as an increment of 2. Next increment will be 4. Next increment will be 6 megawatt, 8 megawatt, etc. So this step size y generation is anything you can take it. Here I am taking a step size of 1 megawatt y. Understood? So first it will start from y is equal to 0, then y is equal to 1 megawatt, y is equal to 2 megawatt, 3 megawatt. So like that step size I will be varying this y. So finally what is the value of that is optimized? What is the minimum value? At which value of y you are getting minimum cost? So that we are going to evaluate it. Clear? Now coming back to that equation for F29 is evaluated using this recursive relation. Now how to write here, you see Fn. So same small fn. So I am going to write it here. It is nothing but F2 of 0, 9 minus 0. Hope this first term. This is minimum. Fn. N is 2, no? So that we have taken it. So first I said why I will be using it as a 0. Then with an increment of 1 megawatt like that I will be using it. So y is 0 plus here Fn minus 1. N is 2, isn't it? So 2 minus 1 is 1 of x minus y. What is x? Is 9. What is y we have taken? 0 here. So f1 of 9 minus 0. Is it clear this step? So this is a one term. This is the one combination. That means what? What is the resultant? So F2 means 0 megawatt is assigned to second unit. That means second unit is not operating. 0 units. It is not producing anything. And what about the first unit? The total 9 megawatts, the total 9 megawatt is assigned or will be met by your unit 1. Understood? So this is how we have to read it. So that means that is the thing. Next one, because what we have to do, we have to write all the combinations. Then out of these combinations, which combinations will provide you the minimum value. So that is your minimum cost of generating 9 megawatt by your second unit. Clear? So this is a one combination, comma. So comma, the second one. So I had to increment. I have to increment this 0 by 1. If you are incrementing by 0.5, you can use it as a 0.5. Understood? So if you are using an increment of 2 megawatt, then after 0, you use this one as 2 megawatt. Clear? So the same equation, but this I have incremented here. You see this value I have incremented here. This one. Incremented value of delta. This is nothing but your delta megawatt. Clear? This is your delta megawatt increment value 0 to 1. Now what will be the next term? This remains same. Now once first term is written, so this term will remain same. Okay, fine. So this term remains the same. This unit 2, unit 1 will remain same. Only thing is this and this, the load generation, the generation will vary. X minus y. What is x? Is 9. And y is now, it is 1. Isn't it? So x minus y is 9 minus 1. Clear? So this is the second combination. So that means what? 1 unit of generation will be met by your second unit. That means second unit will be generating 1 megawatt. And here 9 minus 1 is 8. Remaining 8 megawatts will be generating unit 1. Unit 1 will be generating the 8 units. Is it clear? So this is what I am saying it. So hope you understood this one. Next comma, other combination. What is our next combination? This again I am going to increment it by step size of another 1. So it will become F2 of 2. So if it becomes F2 of 2, so you can see F2 of 2, right? Then this becomes 9 minus 2, isn't it? So this becomes 2. So total is will be 9 megawatts. This is how we are sharing the 9 megawatt between unit 2 and 1 by incrementing this y value. Hope you understood this one. Can anyone tell the next term? Next term. What will be the next term? We have to try all the combination. What will be the next term? Anyone? That means you are not followed or what? What is the next term? Or you can unmute yourself to type it. If it is difficult, you can unmute yourself and you can answer it. What will be the next term? See, I should get an answer, otherwise what happens? No. So Gunasmita has given the answer. Okay, fine, it's right answer. Others, I think you are not followed how to write these combinations. All the combination using these recursive relations, all the combinations we have to write it. Each time whenever you are writing the combination, this should be incremented each time. The other values automatically fall in line. Saksham has given. Saksham, check the sign. So next term will be the same term, but this will be incremented by 3. So if it is be incremented by 3 means this becomes 9 minus 3. This becomes 9 minus 3. So this becomes 9 minus 3. That will be your next term. You see this one? This is the only, you see, this is what we are incrementing it. 0 to 1, then 1 to 2, isn't it? You can see clearly here. So 0 to 1, then 1 to 2, we are doing it. Okay, I think annotation is not coming. Yeah, now it might come. This is, don't know what happened. Yeah. 1, 2, 2, then 2, 2, 3. You see, this is the increment. We are doing it. 0 to 1, 1 to 2, 2 to 3. The other term automatically will fall in line and this will not vary. That means this term and this one will not vary once you are written this first term. Only thing is here it is going to vary this point, isn't it? So what is this? Total megawatt is 9. So 9 minus 2 you will get. So like that. So what will be the next combination? What will be the next combination? What will be the next combination? Again, this term incremented to 1. So that becomes 4. F3 of 4 plus F1 of 9 minus 4. Next combination will be F2 of 5, F1 of 9 minus 5. Then F2 of 6, 9 minus 6. So till which point we'll see this one. So till you get capital F as 0. Because small f we have started with 0. So you have to write all the combination till you get capital F as 0. 9 minus 7. Then again this is 7. So next point it will be incremented to 8, F2 of 8 plus F1 of 9 minus 8. Then this is F2 of 9. 9. Okay, sorry, this is 9. This is 9. This is 9. This is not 8. Understood. So now you can see f1 of 9 minus 9 is 0. There ends. So this many combinations you are going to get. This many combinations you are going to get. Now close it. This is a open bracket, isn't it? So braces. Now close it. That is the final combination. Close it. Okay. This is how you have to write all the combination for f2 of 9. Hope you understood. Suppose, okay, first let me complete this one. Hope this is how you have to write. Now what you have to find out? You have to find out these values. Each combination value you have to find out. After determining the combination values, which combination has got minimum value? Because the whole is minimum. Which value has got minimum value? That will be the value of your F2 9. So that's what you have to do it. So the next step will be, so I am writing this one, resultant, nothing. It is same as this one. 9 minus 0 is 9. 9 minus 1 is 8. So 9 minus 2 is 7. That's what, same as this one. Only thing is, I have removed this 9 minus 7. I have written it here. Same thing. Now what we have to do, each combination value we have to determine. What is the value of this combination? What is the value of this combination? What is the value of this combination? I have to determine. So how to determine this one? Let us see. So we are estimating F2 9. We are moving on to the next slide. Please keep it in mind. This recursive solution as well as now what we are doing it right now is F2 9 we are evaluating using recursive solution. Hope till this point you understood this one. Next step is we have to evaluate the value of each combination. Okay, first F2 of 0, F1 of 9. Isn't it? Okay, that we will do it. Let me remove this one. Okay. Okay, again, the same table which has been given, unit 1, 2, 3, 4, with A and B values, I have represented here because we have to use these values here. That's why I represented here. Now let us calculate it. First combination. What is that first combination? Now here, what is this value here? Already we have done it. What is the value of this one? F2 0, F1 of 9. What is the value of this one? Can anyone tell what is the value of this F2 of 0, F1 of 9? What is the value? F2 0 means unit 2 is not producing any generation 0. That means it is not operating unit 2. Okay, so unit 2 is we are not operating, that is not existing. So what is existing? Only F19. That means unit 1 will be generating the whole 9 megawatt. The unit 1 will be generating the whole 9 megawatt. So we want the value of F19. What is the value of F19? Already we have found that one in the earlier slide, isn't it? That is how much? 242 point something we have found it. So if I can go back, I will show it to you. You see here, this is your F19, isn't it? So what is the F19 value we got? Something 242. You see here, 242.685. Remember this one. So that itself is your F19. Okay. So that's what the value we got it here. This combination value already we got it, isn't it? So next so what is this value? First value 242.685. That value we got it. Now F2 of 1 plus F1 of 8 we have to evaluate. We have to evaluate this combination value. So let us see that one in the next slide. So let us remove clear the drawings. Fine. So next. So F2 of 1, same equation, same cost equation, use it. So F2 of 1, that means 1 megawatt of generation will be generated by second unit. So if it is so, if 1 megawatt is generated by second unit, then what is the cost? So use the cost characteristic equation, and this is unit 2, isn't it? Unit 2, unit 2, unit 2. So what is the unit 2 cost here? Unit 2. This is the unit 2 costs. So what is A? 1.6. Then what is B? Is 26.5. D is 0. Substitute those values. Please be careful while substituting. This is for unit 2. What are the values of A and B and D? Substitute. D is anyway 0. Substitute A, B values, given values, that is equal to this one. And what is PG? PG means this bracketed term, the generation value. Understood? So it is generating 1 megawatt. Is nothing but your PG. So that value is substituted. This A, B, D from the given table. This is nothing but your this 1 megawatt. So that value is substituted. So you are going to get 27.3. I have not written the unit. So it is nothing but rupees per hour. 27.3 rupees per hour you are going to get. F2 of 1. So next what we should evaluate? What we should evaluate here? This is what we are evaluating. F2 of 1 we got. F1 of 8 we have to evaluate it. F1 of 8. So what is F1 of 8 is equal to same cost equation, use it. Same cost equation, use it. So this is which unit you are doing it? 1. Unit 1. Unit 1. This is unit 1. Understood? So this is unit 1 we are taking it. So what is the value of A? 0.77. What is the value of B? It is 23.5. Because this is unit 1. So corresponding A, B, D values we have to take it. Substitute these values here, AI, BI, DI. What is PG? Is nothing but your 8 megawatt. PG is nothing but your 8 megawatt. Hope you understood that one. This is nothing but your this value. This 8 is nothing but your PGI. Substitute it. Understood? So when you substitute those values, so what you are going to get? You see those values, substitute it. So 0.77 is AI, 23.5 is BI, DI is 0. If DI is also given, plus you add it, plus the value of given DI. Here DI is, D values are 0. And here PGI is your 8 megawatt. So when you compute this one, so you are going to get 212.64 rupees per hour. I have not mentioned unit, but you have to mention it. 212.64. This is the second combination, isn't it? So second combination, what is the total value? F2 of 1 plus F1 of 8 is the second combination. So add 27.3 plus 212.64. That will be the value of your second combination. Okay, that we will do it later. Okay, now this is the value we got it when we add it. This is your second combination, F2 of 1 plus F1 of 8. These two we add it. That is 27.3 plus 212.64. It is 239.94 rupees per hour. Rupees per hour. 239.94 rupees per hour. I have not mentioned it. Okay. Second combination is over. First combination already we have done, so we have not calculated. Second combination we have just now done. The third combination. So what is the third combination? We can see here. What is this is over. Third combination is F2 of 2 into F1 of 7, not into plus. F2 of 2 and F1 of 7 you have to take it. Why AI values are different for F1 capital F? Oh, just now I said. Okay, I will explain. Okay, now the third combination, please remember, what is the third combination? F2 of 2, F1 of 7. So find out F2 of 2, F1 of 7. So add those two. So that will be the value for your third combination. Understood? So that I will give it to you here. Okay. Now the doubt Saksham has asked, why this AI, BI values are different for small f and capital F. See, Saksham, focus on this unit. For small f, what is this one? It is unit 2. Unit 2. So, what are the coefficients for unit 2? AI and BI, these are the values. Red line I have shown. For unit 2, 1.6A and B is 26.5. That's what we have taken it. And when you come to capital F1 of 8, this is unit 1. You focus here, this number. This is unit 1. Unit 1, A coefficient is 0.77 and B coefficient is 23.5. This is the given values. So that's why your AI, BA values are different for your small f and capital F. Why it is different? Because you see the unit here it is second unit and here the unit is first unit. So corresponding values we have to take. Hope you understood this one. Okay, now the second combination is over. Third combination F2 of 2, small f2 of 2, we have to find out. Same equation. Now this is, now you see F2, that means second unit. Second unit. A, B values substituted, D is 0. And what is PGI? What is the value of PGI? 2 megawatt. PGI is 2 megawatt. Understood? So that 2 megawatt you substitute here. Hope you all understood this one. AI, BI for second unit, this one. I will show you. So this one. This is your second unit. Understood? So that second unit values you have to take it. Okay, so this is equal to 56.2 rupees per hour. I have not mentioned unit. Please, you have to mention the unit there. Rupees per hour, 56.2. And what is the other thing? It is F1 of 7. Sorry, F2 of 1. Third combination is F1 of 7. You see that equation, previous equation. So F1 of 7. Same equation. Now what is AI, BI, DI values? Here you see unit 1. Unit 1 value. Unit 1 value. AI values 0.77, BI values 23.5. Those values you substitute. And what is PGI? Is your 7 megawatt. PGI is your 7 megawatt. You substitute those values. So you will get the answer as 183.365 rupees per hour. Clear? This is what 183.3665 rupees per hour. Hope you understood this one. Now what is the total cost of this combination? Third combination. Third combination. So what is the total cost? F2 of 2 plus F1 of 7 is equal to 239.565. When you add these two, so you are going to get 239.565 rupees per hour. Are you following it? So this is the value of third combination. Okay. Now fourth combination. What is the fourth combination? We have to find out. Can you tell me what is the fourth combination will be? F2 of 3 plus capital F1 of 4. F2 of 3 plus capital F1 of 4. Understood? So that combination you have to find out. So let us see here. Okay. That animation I have not done. Okay, can anyone calculate and tell me the value? F2, the fourth combination value. Fourth combination value. Fourth combination will be F2 of 3. This is incremented by 1 megawatt. We are considered increment value as 1 megawatt. You can consider, if you want better accuracy, you can consider 0.5 megawatt. But you will get more number of combinations if your increment is less. And if your increment value is more, like 2 megawatt, you will get less number of combination, but you have to compromise on accuracy. Understood? So, but nominal value of 1 megawatt generally we will take, so we have considered that one. So next fourth combination will be F2 of 3 plus F1 of 4. What is the value you are going to get? Please calculate it and tell me. Because already 3 examples I have done it, 3 combinations. Fourth combination, what is the value? Because I have to see whether you understood this one or not. I am going slowly, step by step. You calculate it. What is the value of fourth combination? The fourth combination will be small f2 of 3 plus capital F1 of 4. Sorry, 3 means 9 minus 3, 6. Sorry, 6. I think the fourth combination will be f2 of 3 plus capital F1 of 6. I think earlier I said 4, I think, if I am right. What statement I made? If it is 4, then I am wrong. So the fourth combination will be F2 of 3 plus F1 of 6. Now recalculate it and check. Okay. So you are taken F1 of 6 now? This one? Okay, fine. So you are given the value. The others, please you try. So it is 241.56. Okay, similarly, those who are completed, calculate it for fifth combination. What is the fifth combination? F2 of 4, F2 of 4 plus F1 of 5. Like that, all the combination values, please calculate it. Please calculate it. So after getting these values, all the combination values, which combination value has got minimum? That we have to pick it up for F2 of 9. This is what we have to do it. Okay. So anyway, we will continue this one in the afternoon class. 3 o'clock I will be engaging it. We will continue and we will finish it off this unit commitment topic today at any cost. I plan to complete it now only, but anyway, because I am explaining slowly, so it is taking more time. Anyways, so I will continue the class in the afternoon. So one more thing I want to tell you regarding those students who are going for placement activity. So whatever the attendance we are entering e-governance, as per the actuals we are entering it. I am entering it. Understood? As per actual strength I am attending, because the actual strength which I am copying it from the Zoom, that should match with the e-governance number. So that's why whatever actual attendance is there, that I am entering it in the e-governance. If you attended placement activity, I will give the attendance, but in the e-governance, so it will be marked as per the actual class. Because legally it is not right that marking present here, how can you be there at both places at the same time in the class as well as placement? So that's why don't worry, if you attended placement, that will be given as a present or marked as a present in my actual attendance register. However, in e-governance, the actual things I will be marking it. This is for your information, please keep it. So because yesterday I got so many messages, I have responded also because of you people have attended placement. No problem, you can convince your parents that because of this one, this is what sir has told. So, but physically, I will be giving the attendance in my physical attendance register. Those whoever is attending the placement activity, that list I will be getting it from your placement coordinator. For them, I will be giving the attendance in my physical attendance register. However, in e-governance side, I'll be entering the value as it is, actuals, because that value and my the Zoom count, this one count should match. Clear? For that purpose, I will be entering the actual things. So don't worry, those who are attending placement, you can attend happily. I'll be giving the attendance in my physical register. Hope the message is clear from my end. So thank you one and all. I'll continue this one in the afternoon class. Take care. Bye.